Hi everyone, this is Anushka and welcome back to my channel in Economist. So in the previous few videos, we have discussed about simultaneous equation model and we have gone into the different identification methods where in the previous video, we have already discussed what is the order condition of identification, which I have told you is the necessary condition for identification, right? Now, the only thing that is left in this particular chapter is the rank condition, which is the sufficient condition for identification. So, what I told you was that even if you see the order condition is satisfied, satisfied means there can be two possibilities. Either you will get that exact identification is taking place, or you will see the over identification is taking place, right? So, these are the two conditions when we say that the order condition is satisfied basically, right? If you haven't watched my previous video, I would recommend you to do so because that is the fundamental concept that you have to know before going into the rank condition, right? Order condition needs to be met before understanding the rank condition. So I'll give the link in the description and also in the I tab button. Please check that video and the entire playlist out, and that will help you basically to understand these concepts better, right? Now, today, our turn is to go into the rank condition and understand what this is. So here, if you see, I have written the formal statement. This is the main statement of rank condition. What is that? A structural equation is identified if and only if the matrix which is formed by the coefficients of the excluded variables from the equation under consideration drawn from the system of reduced form equations has a rank of at least g minus 1. Now, I know this statement is very, very complex. If you are, learning this chapter for the first time, you'll be very confused. What is all these things, right? So it is very difficult to understand. But think about this intuitively. See, in order condition, what we said is that we need sufficient number of excluded variables. Remember, so all we need to do is to find out whether an equation is identified or not, whether a structural equation, not any equation, whether a structural equation is identified or not. For that, we have said that in order to identify an equation, we need sufficient number of excluded variables. Excluded means they will serve as an instrument. They will serve as a shifter. Basically, if you remember the diagrammatic explanation which I gave you in some video, there also I have shown you diagrammatically how this shifting thing takes place in the demand supply scenario, right? So the exact similar thing we are doing, but that is only mathematically. Now it is in a mathematical formulation, right? It's a mathematical formulation. So in the order condition, we have said that we need G minus one number of instruments, at least G minus one number of instruments in order to identify equations where we are dealing with G number of total endogenous variables. So if we have in a system of equation, if we have G total endogenous variable, leaving the one endogenous variable that we are concerned in a particular equation, we need at least G minus one number of excluded exogenous variable or excluded instruments, basically instruments that will help us to identify the equation. And that is what we have said in the order condition, right? So the formula that I gave you is k minus m has to be exactly greater equals to g minus 1. If k minus m is the total number of excluded variable that is excluded from a particular equation, but that is included in the model. Remember, we have discussed this thing. K minus m, k is the total number of variables, both exogenous and endogenous in a system of equation. M is the total number of exogenous endogenous variables that are present in a particular equation, but not in a model, in the entire model. And G is the total number of endogenous variable, right? So this we have discussed. So the total number of exogenous variables from a particular equation, which will be given by this difference, K minus M, they have to be exactly, enough. That has to be greater or equals to G minus 1, which is the total number of endogenous variables minus 1, because one variable is included in a particular equation that we are talking about, right? So first condition, which is the necessary condition, deals with the whether there exists sufficient number of exogenous instruments or not. Please remember this thing. Order condition deals with whether sufficient number of exogenous instrument is present in your system or not. If you see it is not present, then you will say the identification is not possible. Your equation will be under identified. And if your equation is under identified, you cannot go into the rank condition in the first place, right? In order to go into the rank condition, firstly you have to check whether your equation is exactly identified or over identified. Then only you can go into the rank condition. Now understand what is the this is all about the order condition that we have already discussed. Now understand what is this statement and what does this mean. What is the rank condition? Intuitively, let me show you intuitively what it means. Intuitively, what we can say, so in the order condition, we have already ensured that sufficient number of instruments are present. Now, in rank condition, we want to check that those excluded variables that we want to incorporate into our model, they must be relevant also. It should not be that they cannot work independently. They are not capable enough to explain the variation of the endogenous variable. That should not be the case. We are saying in case of rank condition, the excluded variable. So beyond that, beyond the order condition, the excluded variable that we have selected for our study, they must be relevant enough, right? So relevant means they must vary independently and affect the endogenous variable through the system of equation. So please understand this thing. This point is very, very, very important intuitively. So mathematically, it's pretty simple to do that. I'll show you with the help of an example, but intuitively understand why we are doing this, why this sufficient condition is also needed, right? So this intuition have to be very clear that why do we need rank condition? Because we have all in the order condition, we have ensured that there exists sufficient number of excluded variables, but we don't even know that those instruments are relevant or not, they are significant or not. So significant or relevant means whether they can explain whether they can explain independently they can explain the variation of the endogenous variable in a system of equation or not, and that is what we were going to check using the rank condition. Now how do you check it mathematically? The process is to check the matrix. How will you form the matrix? See here, I have written that the matrix that will be formed by the coefficients of the excluded variable of the system has a full rank. That is, rank is exactly g minus 1. Rank is exactly g minus 1. That is equals to the total number of variation, that is the variables that are required. If that is the case, if we see that the matrix is of full rank, we will say yes, rank condition is satisfied and the equation is estimable. Otherwise, it is not. So I hope you know what is the rank of a matrix. I have given you a refresher for that also. What is rank? Rank of a matrix is the maximum number of linearly independent rows or columns, right? This I hope everyone knows. If a matrix is of full rank, say rank is exactly equals to 2. So G minus 1, suppose you have total 3 variables, endogenous variables in your model. So you have to see whether the matrix that is formed by the excluded variable of a particular equation but included variables in the model, whether you can form a matrix of full rank that is of order 2 or not. If you can do that, we'll say yes, rank condition is satisfied. If it is not, then we'll say rank condition is not satisfied. So intuitively, it will mean that the two instruments, these are the total exogenous variables instruments that you have. So two instruments, that is the excluded variables being bring in the non-redundant information. So they are independently varying means they will bring about information that are non-redundant. Non-redundant means non-repeated, basically, not repeated information. They can vary independently and they will give us separate independent information about the variation of the endogenous variable, and that is very crucial for our study. Right? I hope this much is clear. Now we'll go into a numerical example and see how do you check the rank condition, right? So that is the main thing, that is the question that often comes in your exam also. So firstly, understand, if you are given this system of equation, the first thing would be, it's a three-step process, but the first thing would be to check for the order condition. First thing is to check for the order condition. This I have already taught you how to check order condition. So let us once again do a quick recap. So for that, you have to know what is the k value, g value, and m value for each of these equations. So let us take the first equation only, right? Start with the first equation and see. First equation, so k value remains always the same. So k will be what? Y1, Y2, Y3, these are the endogenous variables. And if you see x1, x2, and x3, these are the exogenous variables So altogether, you have six variables in the system. So k is 6. This remains same for all the equations. G is the total number of endogenous variable or total number of equations that you have in the system. So that will be equals to 3. Now this m value will vary for each of these equations. So let me call the m for the first equation to be m1. Let me call this to be m1. Now see, m1 is total number of endogenous and exogenous variable present in the equation 1. So this equation, we are talking about this equation, see, 1, 2, 3, 4. So you have four variables, y1 and y2, these are endogenous, and uh, okay, y1, y2, y3. All these are endogenous, and then you have x1, this is exogenous, so m1 is 4. Now what about m2? M2 is the m for the second equation. You have 1, 2, 3, 4. Again, four variables are there. So y2, y1, y3, and x2. So again, for m3. M3 is what? 1, 2, 3, 4. So again, 4. Y3, y1, y2. So again, it is 4. Now, if you have the values available, k is available, g is available, and m for each of the equation is available. So calculate what will be the orders for each of the equations. So k minus m1 if you do, so it will be 6 minus 4, which is 2. And g minus 1 if you do, it will be 3 minus 1, which is 2. Which means k minus m is exactly equals to g minus 1, and the first equation is exactly identified. And if you see, it will be the same for all the three, because see, m value is the same for all the equations, right? M value is the same for all the equations. So you can do this. It's very simple. K minus m2 will also be equals to 2. And g minus 1 doesn't vary, so it is also 2. So it is also exactly identified. And the third equation is also exactly identified. K minus m3 will also be equals to exactly equals to g minus 1. It is also exactly identified, right? So all the three equations are exactly identified. So the order condition is satisfied for all the three equations, right? So this is the first step. This is the first step. Or in your exam, if they have given you for a specific equation, suppose they tell you to find out for a specific equation what is the check whether rank condition is satisfied. So you will do this for the only for the first equation, right? If you see the order condition is satisfied when you are getting either exactly identified or over identified, then only you will go into the rank condition. Otherwise, you will straight away say that the equation is under identified and we cannot go into the rank condition. In our case, it is satisfied, so we are eligible to check for the rank condition, right? So now let us take the first equation, and now let us see how to check for the rank condition. It's basically a three-step process. So what you do? So the first step, step one, first step. Step one, what you do, take everything on the left-hand side of the equality. Here, see, this is the structural equation. I have written this again. What you have to do, take everything on the left-hand side. So the first equation will be like this, y1 minus 5 minus 2y2 plus y3 minus 3x1 minus u1 equals to 0, right? See, everything I have written everything on the left hand side. Do the same thing for the second equation, y2 minus 4 minus y1 minus 2y3 minus 2x2 minus u2 equals to 0. Same thing for the third equation, y3 minus 3 minus 3y1 minus y2 minus x3 minus u3 equals to 0, right? So this is the step one of the process. Now we will go into step two, which is the important step. You have to form a table. You have to form a table of the coefficients of this. Coefficients, only the coefficients of all the variables have to be written. Coefficient matrix, basically, it will be something like this, right? Y1 here, y2 here, y3 here, x1, x2, and x3. So basically, all the endogenous and exogenous variables that are present in your model, you will write it here and will form a table. So let me show you what will be the table. Make a table like this. I'm drawing it freehand, so pardon me for that. This is a table. Now you have to put the coefficients of this, and this. See, from the first equation, what is the coefficient of y1? Let me remove this thing. What is the coefficient of y1 in the first equation? It is simply 1. 1 dot y1. So it is 1. Put 1 here. For y2, if you see, this is minus 2. Put minus 2. For y3, it is again 1. See here, you have 1. For x1, you have minus 3. For x2, See, in the first equation, there is no x2. See here, observe. Let me remove the additional things. Right? So in the first equation, you do not have any x2, so put 0 here. And in the first equation, you do not have any x3 also, so put 0 here. And do the same thing for the second and the third equation. See, in the second equation, do we have y1? Yes, -1. So basically, I'm filling it up with the coefficients of the variables that we have. y2. For y2, you have 1. For y3, you have -2. For x1, do we have x1? No. Put 0. x2, do we have? Yes, -2. x3, we do not have any x3. Put 0. For the third equation, y1 is -3, y2 is -1, right? y3, do we have? Yes, x1. x1 is not present. Then we have x2. x2 is also not present. And x3, do we have? Yes, x3 is minus, right? So this is step number 2. This is the table of the coefficients that we have collected. I hope this step is absolutely clear to you. Now, the third step. Now we have to go into step 3. Step 3 is the most crucial step. What you have to do from this table that you have seen in the, in the step 2, what you have to do, you have to identify all the variables, identify the variables which are excluded from a particular equation, but present in the model, in the model. And how do you do that? For that, you have to check row wise. Take this. For the first equation, this is the row that we got. See, consider only this first row. This is the row that we have obtained for the first equation. Only for the first equation, if you have to check the rank condition, I'm saying. So how do you check all the variables? You have to identify the variables that are excluded from this particular equation 1, but they are present in the model. That will be given by the coefficients where you have 0, right? So we have written in that way only, right? x2 is not present in the first equation. That is why we have put 0 here. x3 is not present in the first equation. That is why we wrote 0 here. So x2 and x3 are two exogenous variables that are present in the system. See, x2 is present, x3 is present. In the system, they are present, but in the first equation, they are not present, right? Can you see this thing? Please observe this thing well. This is the most crucial step that you have to understand well, right? For the first equation. So if you are considering the first equation, first structural equation, so you have two variables, firstly x2 and x3. These are the two variables that are not present in the first equation. So they will act as an instrument. So we have sufficient number of instruments. Now we want to know whether this x2 and x3 are significant or relevant or not. So for that, what do you do? We have to use the rank. We will find out whether the matrix is of full rank or not. So for that, what you do? You have to take this into account. So take this two columns basically. Take these two columns. Under x2, what you have? 0, -2, 0. So right here, 0, -2, 0. And under x3, what you have? 0, 0, -1. So right here, 0, 0, -1. And form a matrix out of this. Form a matrix out of this. This is a 3 cross 2 matrix, if you see. There are 3 rows and 2 columns. X2 and x3 are two excluded instruments. And now you want to know whether they are relevant or not. And that is when the rank condition comes into the picture. So the rank condition says from this 3 cross 2 matrix, if you can form a 2 cross 2 matrix, because see, G minus 1 is 2. Remember, see the order condition. Firstly, we have, use the order condition. G minus 1 is 2 everywhere. G minus 1 is 2 everywhere, right? So you have to form a matrix which is of order 2 cross 2 and which is full rank. Full rank means what? If you find the determinant of the matrix, that has to be strictly not equals to 0. So when you have to see in this 3 cross 2 matrix, from this 3 cross 2 matrix, can you form a 2 cross 2 matrix? Can you form a 2 cross 2 matrix for which if you take the determinant, of this 2 cross 2 matrix, it will return a number which is not equals to 0. If this is the case, you will say, yes, the matrix is of full rank. And then you can safely say that yes, both the instruments x2 and x3 are relevant instruments and the rank condition is satisfied, right? So this is the entire process. Let me show you now. So see in here what we can do. If both the elements are zero, we cannot proceed. So let us take only this portion. Let us take only this. You can take any. This is for a simplified example I have given you, but you have to do like this. Minus 2, 0, 0, minus 1. Right? Suppose I take this matrix and I call this to be say D. Now, if you find out determinant of D, what you get? Minus 2, 0, 0, minus 1. What will be the determinant? If you do this multiplication, it will be minus 2 into minus 1, which is equals to 2, which is not equals to 0, which is not equals to 0. So we are able to find out a 2 cross 2 matrix, which is full rank. Full rank means the rank is exactly equals to 2. It means there are two linearly independent rows or columns are present in the matrix. That is why it is a full rank matrix. It is a full rank matrix. So this basically ensures that both the instruments are valid instruments, right? Full rank means both x2 and x3 are relevant instruments or valid instruments. That is why rank condition, which means the rank condition satisfies. Rank condition holds. Rank condition holds. So the first equation qualifies for estimation, right? The first equation qualifies for estimation. So firstly, check the order condition. Let me again repeat what I have done. Firstly, check the order condition. We have seen the first equation is exactly identified, which tells us that we are able to go into the rank condition. Now, what do you do? Three-step process. First step, write everything on the left-hand side. Second step, form a table of the coefficient matrix. Third step, identify from this coefficient table, identify all the variables that are excluded from a particular equation but present in the model. That will be given by the zeros in a particular row, as I have told you. Now, once you have those particular columns, you can form a matrix like this. Now you have to say now you have to see whether you can form a matrix of order G minus 1. Matrix of order G minus 1, which will have a full rank, which means for a 2 cross 2 matrix, if you find out the determinant, if it gives you not equals to 0, then you will say the matrix is of full rank. And then you can safely say that yes, x2, x3, not only they are, necessary, but they are also sufficient because they are also relevant. So we should incorporate them into our model and hence the rank condition holds. So for example, let me show you another equation. Let me go into the second equation and see. And the third equation, I will give you a homework that you will do in your free time. For the second equation, if you see, we'll follow the same step. So now we are considering the second row basically. The second row, see, where do we find the zero? This is a zero and this is a zero. So now we'll work with x1 and x3. x1 and x3 are two important instruments for the second equation. Now again form this matrix. So x1 is minus 3, 0, 0, minus 3, 0, 0, and x3 will be 0, 0, minus 1. 0, 0, minus 1. Now again you have to check. So this is again 3 cross 2. Again you have to check by the rank condition whether you can find a 2 cross 2 matrix where the determinant will be not equals to 0. So one such matrix will be, so 0, 0 again we cannot work. So we can go with this and this. So minus 3, 0, 0, minus 1. This is a 2 cross 2 matrix. Find out the determinant. The determinant will be minus 3 into minus 1, which is equals to 3, which is again not equals to 0, which again satisfies the full rank condition. So rank condition again holds. Rank condition again holds, right? So this also satisfies. The first equation also qualifies for estimation. Second equation also qualifies for this estimation process. Now I will give you a small homework. Do it for the third equation. Use this table. If you want, you can take a screenshot or do it by yourself. Take this third equation. Here what you see, this is one of the excluded variable. This is another excluded variable. Try to find out whether you can find any of the 2 cross 2 matrix which has a determinant not equals to 0 and whether that is estimable or not. What do you think? What will be the rank condition? And I have given you another separate problem as your homework. See, this is also a homework problem. So this is a fresh problem. So for this problem, find out what will be the order condition for each of the three structural equations and whether they satisfy the rank condition or not. And let me know in the comment section what you get. And if you have any questions anywhere, if you have any doubts anywhere, you can always let me know in the comment section. I will be more than happy to reply to your doubts. And I hope you like this video. You have learned the process entirely. And you like my endeavor to explain these things in a fashion that is understandable to most of you. If you really like this video, then hit the like button and do subscribe to this channel, AN Economist, because this helps me immensely to grow my channel and to keep on making such useful videos for you in my busy schedule, right? So if you like my endeavor, then do support my channel, show your love and support. Don't forget to subscribe to this channel, AN Economist, right? And in the next day, we'll start with some other topic and we'll again discuss some important points on that, right? So thank you so much for your time and let's meet you in the next video.